Hello, this is the distance formula video lesson. Make sure you have your worksheet and a calculator with you, and we're going to try some distance formula examples. We're going to start with the definition of distance. The distance is a length or a measurement between 2 points. So let's go ahead and draw on our number line -4, and we'll put a point there. And then on the positive side, making 0 the center there, 2, 3, 4, 5, 6. If we were to talk about the distance between -4 and -6, we would subtract those two values to find out how long that segment is between -4 and +6. So I would do either -4 minus 6, and we would get -10, or we could have done 6 minus -4, and we would have gotten +10. Now there's definitely a difference between these two. One is negative and one is positive. But if we were to take the absolute value of both of them, which is what distance is, the absolute value, or the absolute value is the distance between those 2 points, we would actually end up here with +10 for both answers. And that is because distance is always a positive measurement. And this would be counted another way to say that there are 4 spaces between -4 and 0, and 6 spaces between 0 and +6, and together, just counting spaces rather than using subtraction, we would end up with 10 spaces. So this is distance in a horizontal, and we could have also done this in a vertical manner. But let's take a look at it when we're on the coordinate plane, and we've got this diagonal segment again. So let's call this point A, and it is at x1, y1, and this is point B, which is at x2, y2, and those are just representative of coordinates. Our distance formula is said to be, I'm going to change inks. Our distance formula, or the distance between A and B, is actually said to be the difference between the x values, where this is x1 and this is x2, and I would want to subtract them to see how far apart, just like we did on the number line. So I would say x2 minus x1. Now that would be the distance in the x direction. I would want to do the same thing in the y direction. So here's my first y value, that's y1, and my second y value is right here, and that's y2. So if I want to find out how far this is vertically, the vertical change, then I would have y2 minus y1. So we have the change in the x, which is our difference of the x's, and the change in the y is the difference in the y's. Now, what we actually have here is a right triangle, which we can use the Pythagorean theorem. So we would take these values, we would square them, and we would add them up. Well, we always know that if we were looking for the hypotenuse, the best thing we could do then, what we would do next, is to find the c value, the hypotenuse, is we would take the square root. And that is exactly what our distance formula is. So we would say that the segment AB, the segment between endpoints A and B, is the square of x2 minus x1 plus the square of y2 minus y1. And this is our distance formula. I'll make sure you have that written down. I'm going to write it at the top of the next screen so we can use it on our examples, but once you have it on your notebook, on your note sheet, we should be able to proceed. Okay, let's go ahead and find the distance between these coordinates. So we're going to start by finding our x values, okay? And we're going to subtract them. It doesn't matter which way you subtract them, but if it's easier, let's make this x1, y1, and this one x2, y2, so that we're going to subtract them in the same order. So that would leave me with 4 minus 1, and I'm going to put parentheses and square it, plus, and then we're going to take the y values. I'm going to circle those in a different color here. So we're going to do 3 minus 7, and we're going to square that one as well. And then we're going to take the square root of that. So we're going to do this in a couple steps so that we don't make any mistakes entering it on our calculator. The first step is simple subtraction. 4 minus 3 squared Okay, and then 3 minus negative 7, or 3 minus 7 is negative 4 squared. And that leaves us with 9 plus 16. These are still underneath the square root. This leaves me with the square root of 25, which we know to be 5. So the distance between the two ordered pairs 1, 7 and 4, 3 is 5 units, or 5 spaces. Let's try the next one. I'm going to label these again, x1, y1, x2, y2. And we're going to start with the x's. And I'm going to do 3 minus the negative 2. Be careful with your subtraction when you have negatives. Plus 9 minus a negative 3. And we'll square it, and we'll put the big square root around it. Our next step would be to use subtraction. So 3 minus a negative 2 makes 5 squared. Plus 9 minus negative 3 is 12 squared. And we're going to take the square root after we square those values. So 25 plus 144. If you use your calculator and add those up, we get 169. And when we take the square root of 169, we get 13. So the distance between negative 2, negative 3, and 3, 9 is 13 units. All right, I'm going to give you a second to go ahead and at least set up using the subtraction, the squares, and using your formula to do number 3. Work your way through it and unpause when you've finished and check your answer. Then we'll try number 4. Go ahead and pause now. So I ended up with the square root of 5, and I know that 5 is not a perfect square. So we could find a decimal approximation for the distance between these 2 points, or we could leave it in an exact form, which is the square root of 5. So depending on the type of problem you're working with, if I was just working with these numbers, my best answer is the square root of 5. If I were doing this problem because it belonged to a word problem and I wanted to know the length of a ladder or the distance between two objects in real life, I probably wouldn't tell anybody that the distance is the square root of 5, and I'd probably give them an approximation, which means I'd have to type it into the calculator as the square root of 5. And then I would estimate, and I would round appropriately to give me approximately 2.24. So that is an approximation. Make sure you know what type of answer your teacher is expecting and what type of situations would call for an exact answer versus an approximated answer. All right, go ahead and pause now and try number 4. All right, so perhaps you got to this point and you said, well, the square root of 50, that's not a perfect square either. So we again are left with either choosing to leave it as the square root of 50, which is an exact answer, or we could be looking at an approximation for this. Well, since I know that the square root of 49 is 7, and this is just a little bit bigger than that, I know that this is going to be slightly larger than 7. If we type it in the calculator as the square root of 50, we actually get an approximation of 7.07. So it is just a little bit bigger than the square root of 49. Another way to simplify this would be to be able to reduce the radical, and some teachers may require this and others may not. So if I were to simplify the square root of 50, I would be looking for perfect squares, 25 times 2. Well, I also know that 25 is a perfect square, 5 times 5, and I would go ahead and say, well, this then becomes 5 square root of 2. All 3 of these answers are exactly the same in their values, just that their looks are different. Knowing that these all represent the same thing, and if you were to type the square root of 50 in your calculator, you get 7.07 approximately. If you were to also type 5 square root of 2 in your calculator, you would get 7.07 as an approximate answer. So all 3 of those are correct answers, and you'd need to know what your teacher expects or what type of answers are on your multiple choice answers. All right, great job.